So, in this video, hanggang sa mga susunod, i-discuss ko ay ang aliphatic hydrocarbons. So, aliphatic hydrocarbons are hydrocarbons that do not have aromaticity. So, aromaticity is a particular property of aromatic compounds. Sila yung other kinds ng hydrocarbons na nagpo-provide ng extra stability. So, yung presence ng pi system yun. So, i-discuss natin yun in further detail pagdating natin doon. Pero dito muna tayo sa aliphatic hydrocarbons. So, specific to this video, okay, ang i-discuss ko ay alkanes, okay, yung nature, occurrence, structure, and yung different types ng conformational stability. Sa mga susunod na video, i-discuss ko ang stereochemistry and chirality. I-discuss ko din yung properties, nature, occurrence, tsaka reactions ng alkenes and alkynes. Okay, yung alkenes, alam naman to, these are hydrocarbons with sp2 carbons, yung nagdo-double bond. Alkynes, meron silang triple bonded carbons, yung mga sp hybridized carbons. Okay, so finally, we'll discuss alkyl halides, yung preparation and reactions, as well as their properties and occurrence. Okay? So, in this video, focus muna tayo sa nature and occurrence ng hydrocarbons as well as their conformational stability. So, hydrocarbons are usually found underground as byproducts of fossils or fossil fuels. So, fossil fuels, okay, are distilled fractionally. Okay? So, ang tawag doon ay fractional distillation. Fractional distillation is a distillation process wherein you separate the components of a mixture, especially a volatile mixture, by their molar mass. Kasi kapag mas mababa ang molar mass, mas mababa ang boiling point. Since these are hydrocarbons, yung molar mass at boiling point ay very much directly proportional. Kasi wala masyadong interactions aside from IMFA na London dispersion force. Okay, wala silang dipole-dipole interactions masyado unless nandun tayo sa mga heavier portions. Okay, so yung mga natural gas, they are the lightest components of this fossil fuels. So makukuha nyo ay methane, which is 1 carbon, ethane, 2 carbons, and yung petroleum gas, yung liquefied petroleum gas, C3 to C4, yung mga propane and butane. Yung mga heavier fractions, they undergo further fractional distillation. Okay, tapos makakapag-separate ka ng mga straight run gasolines. Boiling point is 30 to 200 degrees Celsius. C11 to C14 or kerosene, which boils at 175 to 300 degrees Celsius. C40 to C25, yun yung mga gas oil, which boils at 275 to 400 degrees Celsius. So, nandito yung mga high-octane gasoline, yung mga ginagamit nyo sa fuels ng sasakyan. Okay? So, syempre may mga hindi magbo-boil, those are residues. Ang gagawin nila, bababaan nila yung pressure para bumaba din yung boiling point ng mixture. So, kapag nag-undergo na sila ng reduced pressure distillation, okay, ma-separate na nila yung components further. So, yung mga components usually ng residue after further fractional distillation ay mabibigat na. So, for example, this is asphalt, okay, or usually tatawag siyang bitumen. Ito yung ginagamit natin sa roads. So, binders sila ng mga asphalt roads, okay? Sila yung black thing dun sa mga road or mga daanan, okay? So, lubricating oils and waxes, yung mga grease, okay, yung mga long chain ethers and alcohols na usually ginagamit as lubricating agents ng mga gears ng sasakyan. After further purification, makaka-separate din tayo ng mga other lubricating waxes like petroleum jelly. Okay? So that's what happens during the distillation or the separation of components of fossil fuels dun sa mga oil rigs, okay, or sa mga sites na merong fossil fuels. So, for alkanes, there are open-chain alkanes and cyclic alkanes. So, for open-chain alkanes, the combustion energies decrease with increasing branching. So, ano ibig sabihin nun? So, we have octane. So, kapag octane, 1, 2, 3, 4, 5, 6, 7, 8. Yun yung octane. We have 2-methyl heptane. 1, 2, 3, 4, 5, 6, 7. So, 2-methyl heptane. Okay. So, meron din tayong 2,2-dimethylhexane. Nandito naman siya. 1, 2, 3, 4, 5, 6. 2,2-dimethylhexane. And finally, we have the 2,2,3,3-tetramethylbutane. So, butane muna. 1, 2, 3, 4. Tapos 2, 2, 3, 3. Okay? So, 2,2,3,3-tetramethylbutane. Okay? So, pansin nyo, yung combustion enthalpy nila ay nagde-decrease with increasing branching. Kasi nag-i-increase yung stability because of the increase in the number of carbon-carbon bonds per carbon. So, ito kasi mga primary carbons and secondary carbons lang siya. Okay? So, the carbon-carbon bonds are a few per carbon. So, ito, meron ka ng tertiary carbon. So, meron ng tatlong carbon-carbon bond dun sa isang carbon. So, mas stable na to. Okay? So, meron naman ditong quaternary carbon which increases the stability compared dun sa tertiary carbon. And finally, meron tayong dalawang quaternary carbon dito sa structure na to which is far more stable than the rest of the compounds given. Okay? So, makikita nyo din na bumababa yung boiling point because of the surface area decrease from one compound to another. So, ito, maximum surface area niya Okay? Kasi nakalapat siya like a chain or an open chain. Kapag nag-i-increase yung branching like this one, kakaroon ka ng areas na mahirap i-access. So, yung IMFA, no, hindi niya na-experience, okay, with other compounds. So, kapag ganun nangyari, mababa yung boiling point kasi mahina yung iyong IMFA. So, ito ang pinakamahina ang IMFA kasi pinakamababa yung surface area of contact niya. Yung mga open sites lang ay yung mga metal groups. Yung dalawang quaternary carbon ay medyo inaccessible. Okay? So, there. So, as you increase the branching, bumababa ang boiling point at yung combustion enthalpy. So, another thing about alkanes is that their combustion enthalpy increases with increasing chain length. So, ang nangyayari, kapag nadadagdagan ng carbon yung chain, naturally, tumataas yung combustion enthalpy. So, we can observe that there's a subtle difference kapag ang ginawa nyo ay dinivide nyo yung combustion enthalpy niya by the number of carbons ng iyong alkane. So, for example, for propane has a combustion enthalpy of negative 472.2. Propane has 3 carbons. So, therefore, per carbon, ang combustion enthalpy ay negative 157.4. So, just divide negative 472.2 by 3. Yun yung ginagawa nila. Okay? Para ma-compare yung mga combustion enthalpies per carbon. So, pare-pareho lang. Kasi, makikita nyo dito, puro negative 157 yung value niya. However, dun sa first decimal place, ito yung sinasabing subtle difference. Okay? So, may subtle difference daw yung stability ng even-numbered tsaka odd-numbered chains. Okay? So, hindi naman masyadong pansin yung subtlety. So, hindi natin masyadong i-discuss yun. On the average naman, kapag kinuha mo yung average nito, makuha mo ay negative 157.4, which is the value of the combustion enthalpy of straight-chain alkanes per methylene group. Okay? So, per methylene group, that's negative 157.4. So, meron naman tayong isa pang table showing combustion enthalpies of cyclic alkanes naman. So, ito naman ay cyclopropane, cyclobutane, pentane, hexane, heptane, octane, nonane, and decane. So, meron silang 3, 4, 5, 6, 7, 8, 9, and 10 carbons. So, ang ganoon din ang gagawin natin. Yung combustion enthalpy nila, i-divide natin by the number of carbons. Okay? So, dinivide natin yan by 3, 4, 5, 6, 7, 8, 9, 10. Makakuha tayo ng mga values ng enthalpy of combustion per methylene group. So, pansin nyo, hindi siya nag-range dun sa negative 157 to negative 157.7, which is shown here. So, ang range nito ay negative 157.3 to 157.7. Okay? So, yun lang yung range niya. Negative 157.3 to negative 157.7. Yan yung range ng values kapag open chain. Dito, naman, mas varied na. Meron tayong 160 something. Okay? Meron tayong mga 158. So, medyo mas malaki na yung difference. Okay? So, ibig sabihin, merong issue or merong strain added or energy added kapag nagiging ring yung iyong chain. So, that is called the ring strain. So, all we need to do, okay, is to subtract the values given here, okay, yung mga values na to, sa negative 157.4. So, malalaman natin kapag sinubtract natin yung values na to sa negative 157.4, yung energy dedicated for the ring formation only. Yung energy na yon is called the ring strain. Okay? That is the energy required to convert or at least form the ring from its constituent chain. Okay? So that's the energy required, for example, to form cyclopropane from propane. Okay? So this is the ring strain per methylene group. Okay? Per CH2. So ang gagawin nyo, yung ring strain, i-multiply nyo by the number of carbons ng inyong compound. So for propane, for example, 9.2 times 3, kasi tatlo yung carbons ng cyclopropane, makukuha ka ng 27.5 kilojoules per mole na ring strain for the whole cyclopropane. Mapapansin nyo, yun yung pinakamataas. Okay? Kasi, cyclopropane is triangle. Mahirap maka-form ng triangle kasi ang angles nila ay 60 degrees lang yung internal angle. So, napakalayo niya sa 109.5. Okay? So, mapapansin nyo, may connection din to dun sa internal angles na na-form kapag nagkakaroon ka ng ring. Okay? So, for cyclobutane, for example, nagiging 90 degrees yung angle. So, nagkakaroon ka ng ring strain na 26.3 kilojoules per mole ng butane. Okay? For cyclohexane, however, meron tayong 0 ring strain. So, formation of the cyclohexane ring from cyclohexane does not spend any energy or does not require any energy. Okay? So, this, or i-clear out ko lang, this might be connected dun sa angular strain, pero not necessarily. Ang sinasabi ko lang dito, Those are the strains caused by the formation of the ring from your chain counterpart. Ganyan yung energy na needed para ma-form mo yung ring from the chain. Okay? Not necessarily a certain feature of the ring. Kasi may mga ring structures na magkakaiba ng conformation. Makikita natin yun mamaya. Basta ito yung energy associated with the formation of the ring from the constituent chain. Okay? Okay, so for example, that's 26.3 kilojoules per mole is required to form cyclobutane from butane. Okay? So, syempre, may ima-minus pa tayo kasi yung cyclobutane has 2 less hydrogens than butane, pero i-omit na natin yun sa equation. Basta, ang kailangan natin is 26.3. Saan natin i-account yan? That's the formation of the ring from your constituent chain. Okay? So, that's the ring strain. Meron din tayong tinatawag na angular strain. Kasi, syempre, ang rings natin, hindi naman yan constantly flat. Okay? Like a polygon. Some ring structures, okay, bend themselves or nagkakaroon sila ng mga iba't ibang conformations depende sa kanilang structure. So for cyclopropane, hindi ka pwedeng mag-bend ng mga bonds. So yung triangle conformation niya ay constant lang. So therefore, the internal angle is still 60 degrees. Okay, wala tayong changes dyan. Triangle sa triangle, so that's a stiff triangle. Okay, the angular strain is 49.5. Bakit 49.5? A tetrahedral carbon, okay, or tetrahedral sp3 carbon geometry has an angle of 109.5 yung kanyang ligand to ligand angle. Okay, so kapag merong carbon, yung angle na to ay 109.5. Kaso kapag naging ring structure na siya, naging 60. In the case of cyclopropane. So, meron kang 49.5 degrees na angular strain. Kasi syempre, walang strain kapag 109.5. Kapag may 60 degrees ka na lang, syempre, the difference is 49.5. So, that is what we call the angle strain. The strain caused by the deviation of your internal angles dun sa angles nung yung normal sp3 carbon. So, kapag may difference yun, may strain. Okay? So, for cyclobutane, yung flat structure niya is 90 degrees. Mas malapit to sa 109.5. Yung 88 ay puckered. So mas mahirap ngayon ma-form or mas malayo sa 109.5 yung 88 kaysa sa 90. So focus muna tayo sa 90. So kapag 90 degrees, na angular strain is 19.5. Okay? So 19.5 yung difference ng 109.5 tsaka 90. So ibig sabihin may angle strain pa din. Cyclopentane, 108 yung flat. Pero kapag nag-envelope structure siya like this, yung mga angles niya nagiging 109.5. So, 0 yung angular strain ng envelope-shaped cyclopentane. Pero yung flat na cyclopentane, meron siyang 1 degree na angular strain. Okay? So, syempre, kapag ganun, yung cyclopentane, it would prefer the envelope conformation kaysa dun sa flat conformation. Kasi it has the least angular strain. Okay? Yung envelope, mababa ang kanyang angular strain compared dun sa flat. So, the cyclopentane, if it has a choice, yung kanilang most stable conformation ay yung envelope lang. Okay? Cyclohexane, 120 degrees siya pag flat, 109.5 kapag chair and boat. So, usually, chair and boat na lang yung conformation niya. Kasi negative 10.5 yung angular strain kapag 120. Masyadong malaki yung angle compared sa 109.5. So, yung chair and boat conformations na lang yung usually na ina-assume ng cyclohexane. Okay? More probable yun sa structure kaysa yung flat because of the angular strain. Okay? So, for cycloheptane, 109.5 in chair and boat. So, kapag nakita kayo ng cyclopentane or ng cycloheptane, it's most usually in the chair or boat conformation. 144 kasi yung flat, so mataas ang kanyang angular strain. So, mahihirapan yung cycloheptane na mag-assume ng flat conformation because of the angular strain. Okay? So, ngayon, dalawa na yung natutunan natin. Angular strain tsaka ring strain. Ring strain is the strain caused by the formation of the ring from the chain component. Tapos, yung angular strain is the strain caused by the deviation of the internal angles of your ring from the 109.5 degrees equilibrium angle. Okay? So, before we go to the next type of strain, aralin muna natin yung mga conformational diagrams natin or yung mga projections natin. So, kapag staggered, this is an ethane molecule. So, kapag staggered, kita nyo yung bond between the ethane molecule. Okay? Or between the carbons of the ethane molecule. Tapos makikita nyo dito yung bonds or CH bonds ng ethane. So that's how you represent the Sohor's conformation or Sohor's projection for ethane. Kapag naman Newman projection, all you need to do is to put one carbon on top of the other Okay, tapos ipo-project mo siya such that this carbon here is the front carbon, at yung carbon na ito, yung malaking bilog na ito, yan yung carbon sa likod. Okay? Ito yung carbon sa harap. So, makikita nyo, yung carbon sa harap, nakataas yung H niya, which is this. Okay? Tapos, ito yung dalawa. Ito yun. Yung carbon sa likod, ito, which is this. Ito yung tatlo niyang hydrogen. So, 1, 2, 3. 1, 2, 3. Okay? Tapos, meron tayong tinatawag na dihedral angle. Okay? So, this is the angle formed kapag ka ginawa mo yung Newman projection. So, ito across the bond. Ito yung isang carbon-hydrogen bond. Ito yung isang carbon-hydrogen bond. The dihedral angle is the angle formed by the hydrogens or the substituents on two adjacent carbons. Okay, that's the dihedral angle. So, ito yung projection na perfectly makakapag-exhibit ng dihedral angle o makakapag-illustrate ng dihedral angle, the Newman projection. Okay? So, kapag ka maximum, okay, dihedral angle, ang tawag dun sa conformation ay staggered. This is a staggered Newman conformation and this is a staggered Sohor's conformation. Kasi yung dihedral angle between the hydrogens here is at the maximum. Kapag naman eclipse, minimum dihedral angle. So, the minimum dihedral angle is 0. Kasi, ito, yung angle between here and here is 0. Kasi, halos pantay sila. Okay? Ginawan ko lang ng slight difference para makita natin kung ano yung harap at likod. Pero, this angle is almost 0. Okay? That's the minimum dihedral angle. So, kapag ka magkalapit yung, or pag minimum yung dihedral angle, mapansin nyo, apparently, mas magkalapit yung hydrogens. Tapos, kapag maximum, medyo magkalayo sila. So, the strain caused by the minimization or the reduction of the dihedral angle is called the torsional strain. Ito yung tinatawag na torsional strain. Okay? Torsional strains are strains caused by the minimization or by the reduction of the dihedral angles between two adjacent carbons or the substituents of two adjacent carbons. Okay? So, kapag ka sa cyclohexane na, mapapansin nyo, this is the chair conformation. So, chair conformation, okay, makikita nyo, yung Newman projection niya, lahat ng angles ay staggered. Maximum yung dihedral angles. Pero kapag flat yung cyclohexane nyo, lahat ng angles ay naka-eclipse or lahat ng substituent ay naka-eclipse dun sa kanilang kapwa dihedral. Okay? So, kaya mataas ang strain kapag ka flat compared kapag ka chair or both. A both conformation. So, kapag chair, lahat ay staggered. Kapag flat, lahat ay eclipsed. So, makikita nyo yung malaking difference dun sa torsional strain ng cyclohexane conformations. Okay? So, makikita naman natin dito yung mga Newman projections ng mga unsubstituted ethanes tsaka disubstituted ethanes. Okay? So, makikita nyo dito sa diagram ng mga unsubstituted ethanes na umiikot lang yung bond na ito, okay, yung itong tatlong substituent na to around the carbon-carbon bond. So, if we draw the Sohor's projection, okay, umiikot lang tong harap na to, okay, clockwise. Okay? So, makikita natin kapag umikot siya from this maximum dihedral angle of 60 degrees. Okay? This is actually 60 degrees kasi 60, 120, 180. So, this is 180 degrees. So, that long 60 degrees yan. Okay? So, since 60 degrees yung maximum dihedral angle for a staggered conformation, pag inikot mo to, magiging almost zero. So, magiging eclipsed yung conformation. So, syempre, meron tayong tinatawag na torsional strain. The torsional strain is maximum kapag meron tayong eclipsed conformation kasi minimum yung dihedral angle niya. Ibig sabihin, zero yon or almost zero. So, kapag inikot pa natin to, pabalik tayo dun sa staggered conformation, nakapareho lang ng staggered conformation number 1. Okay? So, ang mga ikot natin dito ay 60-degree rotations, okay, around the carbon-carbon bond. Okay? So, tingnan naman natin yung mga disubstituted ethanes. So, makikita nyo, meron siyang dalawang R. Yung dalawang R na to, ang distance nila, okay, sa dihedral ay 180 degrees. So, this is the maximum possible distance between two substituents dun sa dihedral angle. Okay? So, pagka nirotate natin, okay, yung front carbon or yung substituent sa harapan with respect dun sa carbon-carbon bond na Yan. Okay? So, pag nirotate natin ito ng 60 degrees, makakuha tayo ng eclipsed one where the front substituent is in contact with the hydrogen dun sa likod na carbon. So, this is an eclipse torsional strain caused by the eclipsed conformation. So, yung interaction ng R at H ay maximum kasi minimum yung kanilang torsional or yung kanilang dihedral angle. Kapag inikot mo ulit to ng 60 degrees, makakita naman tayo ng ganitong conformation. This is staggered conformation. Maximum yung possible dihedral angle kasi staggered siya. Pero, 60 degrees lang yung angular distance between yung dalawang heavy substituents. Okay? So, compared dito, syempre, less stable yung staggered 2 because of the so-called gauge interaction. So, the gauge interaction is a staggered conformation pero magkalapit yung malalaking substituents. Okay? So, the least stable conformation is of course the eclipse conformation wherein the dihedral angle between the heavy substituents are at the minimum. So, ibig sabihin maximum yung torsional strain between the two substituents. Okay? So, pareho na lang din ang mangyayari kapag further ni-rotate mo pa to. Okay? 60 degrees, magkakaroon ko ng staggered 3 which is equal to the staggered 2 conformation. Magkakaroon ko ng eclipsed 3 which is equal to the eclipsed 1 conformation. And finally, you will reach staggered 4 which is equal to the staggered 1 conformation. So, pwede natin actually i-plot yung energy niya. Okay? Energy through an energy diagram. Okay? So, syempre, yung torsional strain will be the energy. Okay? So, kapag minimum yung torsional strain, mababa lang yung energy. So, syempre, from the staggered 1, minimum yung energy. Okay? So, aangat siya from the eclipsed. Kasi eclipsed conformations are less stable than staggered conformations. Mas bababa siya ng konti kasi although this has a gauge interaction, mas mababa pa rin yung energy niya compared dun sa mga eclipsed conformation. This is still a staggered conformation. Okay? So, syempre, this eclipsed conformation has the highest energy kasi nag-i-interact yung dalawang malalaking substituent. So, syempre, yung staggered 3 equal lang sa energy ng staggered 2 because of the gauge interaction. And the eclipsed 3 is just equal to the eclipsed 1 energy tapos minimum ulit pagdating sa staggered 4. Okay? So, ganyan yung pag-plot natin ng energy ng torsional strain. And this is how to actually illustrate yung differences ng mga energies or mga torsional strains between various conformations. Okay? So, I hope you learned something dito sa conformational stability. Meron tayong tatlong types. Meron tayong ring strain. Meron din tayong angular strain caused by the ring formation or the various conformation in the ring structure. At meron din tayong torsional strains caused by the adjacent carbons and substituents interacting at the dihedral angle. Okay? So, I'll discuss further details about this in the next videos. Okay? So, see you next video.